A hungry snout digs through frozen padded snow, looking for a hidden prize. The sniffer manages to uncover the tip of a botanical reward, and putting in one last great push of effort, claims its meal. Rinse and repeat 1,000 times more. But this one is unusual. She has failed to lay even a single egg, and with other adults, specifically males, already dying out, her options are becoming more and more limited if she wants to pass on her genes. Letting out another mating call into the billowing snow, she is met with the soft whispers of stormy winds, and with more disappointment. Unbeknownst to her, she will be the last adult sniffer for a very long time. Hello, my name is Organ Candy, and in this video I'll go over the speculative biology of the sniffer, how they evolved, how they work, and even how they might evolve in the future. The sniffer was previously thought to be an extinct animal, lost to the crushing hand of time. And who could blame the common consensus for that? Outside of obscure remains, which could frankly be many different things, the only traces of the sniffer species were frozen corpses dated hundreds of millennia ago. That was, until recently. There's been a new boom in archaeology, and with it, the unearthing of long-lost relics, both crafted by the hands of people and the bodies of animals. One group of finds is of particular interest to this video: viable sniffer eggs. This discovery sparked many debates and inquiries into an animal once thought to be relegated to obscure fun facts books and the back memories of academics. Now not only do we have an opportunity to learn more about this specific organism, but more importantly, to test many of our previously held notions about life. Firstly, a major question that needs answering is how these eggs remain alive for such a long time, and more importantly, why do they hatch now? The first one is due to a phenomenon called cryptobiosis, one of the strongest forms of dormancy. In fact, this form of dormancy is so strong that organisms can survive for thousands of years under suspended animation. Such a feat is achievable through a few methods. When triggered to enter cryptobiosis by adverse environmental conditions, a sniffer egg will slow down the metabolism of the developing embryo to the point of a complete cessation, and create a variety of preserving chemicals, with the goal of outlasting whatever threat is facing them. Secondly, why do they hatch after so much time? The answer is simply because now is when the environment is most hospitable for them, at least when compared with the past 1,000 or so years. What's really interesting is the egg's ability to detect its surroundings and decide when it should hatch. The egg must consider multiple things in order to make this choice. What's the temperature? Do the surroundings have the right air composition? Are there potentially noxious toxins? Very impressive. Prehistorically, the sniffer would go dormant for much shorter periods of time, usually less than a year, or at most, multiple years. However, as luck would have it, this trait allowed survival over much longer periods. Here, the individual egg is currently exposed to a comfortably warm environment, enough to trigger the rapid revival of the developing baby within. But why do they hatch so fast? Were we simply lucky to have every single sniffer egg beyond the cusp of birth? Not exactly. What I believe is going on is that sniffers have evolved to hatch incredibly quickly. Let me explain. Sniffers evolved during turbulent times, hence their adaptation of cryptobiosis eggs. This also carries the implication that the good times are short-lived. In order to capitalize as much as possible, sniffer eggs have evolved to shoot out the baby the relative instant it would be desirable to do so. If they didn't do this, then the sniffer would obviously take a longer time to be born. Not a winning strategy in a highly competitive environment with very limited resources. Best to go out early so they can get a head start on eating compared to slower hatching individuals. This has led to the sniffer incubation period being extremely short, only 1 day, with the curious factor that when placed on moss, the egg takes half as much time to hatch. Now why is that? Why would moss be special? Well, I believe that moss isn't unique in triggering faster incubation rates. It is simply more effective at it than simple grass. We've already discussed how the eggs need to detect the outside environment, and one of the things that needs detecting are certain biosignatures, things that tell us life, that is, food, is around. and moths may produce an excess of these signatures. Needless to say, the eggs kicks into overdrive so that the sniffer within can consume said food before anyone else does. Speaking of which, let's talk about what the sniffer eats. A shockingly selective diet of only one plant, the torch flower. Further limiting their diet, sniffers will only eat the plant's seeds, and based on the visuals, you may have guessed that sniffers will also dig up pitcher pods, but will ignore them. Now, there is a solution. The sniffer used to eat far more, but all the species they used to eat have gone extinct. That still asks the question, is it normal for animals to be this picky? After all, with what we know about the environment the sniffers evolved in, and the wide range of food they likely exploited, why can't they adapt modern species into their palates? Perhaps the answer is simply that they never needed to, and don't, even now. You can very clearly see that sniffers can find all the food that they need just fine, because if they couldn't, they would perish. In fact, finding these two plants is so easy for the big fluffy behemoths, it begs the question of how we missed them for so long. Oh well, we might have just gotten unlucky. You might have noticed that I called these animals fluffy, and you've probably noticed that these animals are indeed endowed with a thick coat, regardless of what I said. With this, we can assume that they evolved in a primarily cold environment, where layers would be important for sustaining a healthy body temperature. On the other hand, when revived today, these animals can do just fine in incredibly warm environments. How? Well, animals with fur pelts can certainly thrive in the desert, but even comparing the two, the sniffer is definitely a lot furrier than their modern neighbors. So what's the secret? Well, the iconic snaz mainly, specifically the nostrils on said snaz. Due to their species normally inhabiting chilly environments, the sniffer evolved constricted nostrils better to prevent loss of body heat. It just so happens that these nostrils can widen due to their flexible nature, allowing the opposite to occur, that is, the venting of heat. Depending on the environment the sniffer inhabits, their bodies adapt accordingly. Now, let's focus on another use of their snouts: digging. Each sniffer has a hard keratin tip on its nose that acts as a shovel head, though due to their blocky form, the digging process is much more similar to a messy storm of debris than any careful extraction. Sniffers usually dig to find food, though burying eggs may still be on the table. Such massive noses also help detect things, like when they're buried under feet of snow, or in the modern day, deep underground. The main body is mostly fat, used to store extra calories. The bulk of its form is supported by 3 pairs of legs, which prevent the sniffer from sinking into snow or getting stuck, usually. Lastly, each leg is capped with hooves to prevent heat loss through fleshy surfaces. Within, the sniffer boasts a long intestine, best to maximize the amount of nutrients extracted from their meals. Now, I've been talking a lot about food, but how did the sniffer prevent themselves from becoming food? After all, in the frozen world they evolved in, many other organisms would also be quite hungry, and it's difficult to imagine the sniffer putting up a fight due to their lack of dexterity, weapons, and pacifistic nature. And equally difficult to imagine them running away on their short stumpy legs. For the adults, such a thing could be quite simple: their sheer size. Yes, this may have made them a major target of predators, promising spoils to last multiple meals hidden within them, which as easily could threaten a messy end. Of course, we know that the bark of a sniffer is much more than its bite, the threat empty, but potential predators don't know that. You may have noticed I said, for the adults, and I did so for a reason. Sniffers start off relatively small, and unlike their parents who can rely on bluffing to survive, these snifflets truly have nothing to protect them, as their species is a solitary one, and will not even herd to defend them using numbers. While we are on the subject of such morbid things, let's talk about ways the sniffer population could have gone extinct to begin with. A few possibilities present themselves. The first one is simply the fact that sniffers are energy-intensive creatures who need many calories to live. Sheer starvation could be the simplest reason for their demise. Another reason may be their inability to defend themselves. After all, animals can be quite clever, and over time may have been able to call the sniffer's bluff. Perhaps the sniffer's legs were unable to navigate difficult terrain, which would have surrounded the species. Maybe the simplest reason was that these animals were outcompeted by their smarter, less needy, and overall better adapted compatriots. After all, you don't need to be bad to fail, just worse. Whatever the reason, this species declined in population. The eggs left behind were slowly picked off by scavengers until the only survivors were encapsulated in a watery vault, further shielded by a thick layer of hardened sand. But now they have been rediscovered. So what waits them anyways? Obviously we can't truly know for certain, but using some quick deduction we can come up with a few theories. Firstly, it is quite the common opinion that sniffers are adorable animals, with their large fluffy bodies, stubby legs, and their ability to sploot when the sniffer lies on their stomach and sticks their legs out to the side. Combined with their calm temperament and relatively simple care, I can easily see these creatures becoming domesticated pets, owned by families of all stripes. The new household sniffer would gain enhanced characteristics of what people considered cute, for example, enlarged eyes and even more droopy ears. Ultimately, adults of this new animal would be only marginally bigger than their ancestors' babies. The sniffer may become more active as selective breeding brings out desirable behaviors in the species. Furthermore, docility might increase, and so might affection. However, there is a darker approach to their future, one that follows similar themes of domestication, as food, as clothing, and as jewelry. Many parts of the sniffer could be very coveted, not just for the clout the animals hold as a resurrected species, but the sheer utility such a creature provides. Farmed sniffers might gain massive amounts of body mass, both in meat and hair. Their snouts might become larger than their entire bodies. The eggs of the sniffer might be forced to undergo constantly accelerated birthing, utilizing their inbuilt system for maximizing food production. While it could go on, I think you get the idea. A neutral ground could be reached, where sniffers are not beloved pets, nor farmed food, but instead pack animals, used to pull and carry supplies. Of course, given the stubby legs of the sniffer, this seems the least likely, as it would take too long for them to move. And faster, more effective animals already exist to fill this niche. Lastly, and perhaps the most interesting possibility I will explore, is what happens when sniffers are left to their own devices to evolve by themselves in the wild. Firstly, sniffers are probably brought in their diet, and begin eating plants on the surface. It would be more efficient than digging in the ground for sustenance and probably wouldn't require a major overhaul of the sniffer's body. The second and last change we would see is a behavioral one. Sniffers used to be solitary creatures, as otherwise whole herds of sniffers would simply clear away any food in an area and starve the population. However, in a time of plenty, these animals would gain many benefits from the now sustainable practice of forming groups, including increased protection, access to mates, and even, perhaps, ways of raising children. All other potential changes are, to me anyways, mere guesswork. Perhaps they gain longer legs for running or fighting. They gain a mean demeanor for defense. Maybe they grow spines or venom glands. Maybe they even gain the ability to breathe underwater. The sniffer might become a multitude of unique animals. Anyways, thank you for watching this video, and have a good life until next time.